Hey there, Mr. Wilford here. Just wanted to go through Chapter 6, Section 2 with you today and talking about properties of parallelograms in this section. If you remember in the last section, in Section 1, we were talking about polygons and what some different kinds of polygons are. And in particular, we're going to talk about a quadrilateral with four sides. And let's talk a little bit about a parallelogram first of all. A parallelogram is going to be a quadrilateral with two pairs of parallel sides. So as an example here, I have a parallelogram where sides AB and CD are parallel to each other, as well as sides BC and AD. Those are also parallel to each other. And the first theorem here, properties of parallelograms, theorem 621, it's saying if a quadrilateral is a parallelogram, then its opposite sides must be congruent. So if we know that we have a parallelogram, what we can say then is the sides opposite each other, for example, AB must be the same length as CD, and BC would be the same as AD. And so we can talk about these parallelograms, and the sides we know that are opposite are going to be congruent to each other. So if we take a look then at some other properties here, we have three different theorems. And real quick, the first one here, 622, if a quadrilateral is a parallelogram, then its opposite angles are also congruent. So you can see here that angle B and angle D are congruent, and A and C are congruent. So those are some other things we can tell about a parallelogram. Theorem 623, if we have a parallelogram, then its consecutive angles are supplementary. So remember, supplementary, we add the angles and it's going to equal 180. So this is a nice theorem saying that if we take angle A and B, for example, if we add those up, we're going to equal 180 degrees. In the same way, angle B plus angle C will equal 180 as well. And then the last theorem here, 624, if we have a parallelogram, then the diagonals that are going to bisect each other. In other words, they're going to cut each other in half. So we have the diagonal BD and AC. Well, where they meet is point Z, and so BZ is going to equal ZD, and AZ will equal ZC as well. So those are a few theorems and properties of parallelograms that we want to be able to use. And you can see here in this application problem, just looking at this picture here, we have a parallelogram and we have diagonals drawn and they intersect at point T. So we can look at a couple of different examples here to find the measure of all these different things. If we want to find the length of PS, for example, the information that we're given up here, we know that the side opposite that is going to be congruent. So we know that if QR is 48 centimeters, we also know that PS is 48 centimeters as well. Here we're using the property that if we add up two consecutive angles in a parallelogram, it's going to equal 180. So we're able to quickly here find out the measure of angle PQR. So that would be that angle right in here. And then this is just using the diagonals bisecting each other. We can look at that example as well. If we continue on, another example using the same sort of thing, except this is not an application problem. It's more of an algebraic problem here. So make sure you take a look at this. There's some good things there as well. And then another example here using the same kind of thing, using kind of a scale drawing here, and finding a coordinate point for that problem. And then we have a couple of proof problems here as well, so make sure that you take a look at those proofs as well. Again, if you have any questions, always please let me know. Thanks.